Hey, it's Johnny Valentine with Gain Solar. Today's video is going to be all about torquing down the lugs on these big 4-auto connections. Whenever you're doing a Sol-Ark 15K, you're interrupting the main feeder most of the time, and it's either going to be 4-aught aluminum or 3-aught copper on a 200 amp service. So you're going to have anywhere between 30 and 50 connections with these high amp wires. There's a PDB right there. There's another one tucked up in the wireway. So you might as well do the best practice on the installation of these wires, which is torquing the terminals to spec. Now, I constantly talk to other electricians, and they say that they never torque to spec. They just tighten it to tight. They know what's good. But when we're doing these jobs, I mean, this is a pretty basic installation for us, and you can see how many times we have this wire being torqued down and junctioned, how many different terminals and places we land these wires. So it just makes sense for us to have a practice where we're minimizing error and the risk of not tightening a wire down tight enough. And when you wonder how tight it is, it always says it on the piece of equipment that you're installing. It's always going to have that torque rating. The last job I was on, it was new construction, and the electrician roughed in some stuff for us, and boom, we go to open up the equipment, and he's torqued it. You can see he made marks, but he made a mistake. I want to show you guys something that I've never actually seen on a job. I've had it close to happening to me, but it's the first time it's actually really come and got me. So these breaker panels are kind of a plastic backing, and then the bus bar is mounted to the plastic, kind of like automotive clips. Those are just kind of like pushed on there. So the bus bar is mounted to that, and all the breakers are on there. Well, whoever the electrician was, when he went to torque this down, see, he torqued that and marked it. But when he went to torque that down, he torqued it a little too tight. He bent it. So when we torque these lugs in the field, we torque them with a torque limiting torque tool, and we actually hold them. So if I was going to tighten that down right now, what I would do is I would have somebody come in, and these are not that close, by the way, but I would have somebody come in and hold it, and while they held it, I would tighten it down so that exactly what's happened there didn't happen. So that stops me from being able to move forward with my project. I'm trying to put a Sol-Ark in. Try to get an electrician to rough in a transfer switch for me. He roughed that in instead. That's a regular safety switch. More expensive too. So we're just trying to keep things safe for you guys. Show you the right and the wrong way to torque something. Okay, so let's talk a second about terminal torque. I've had a lot of conversations with other electricians on whether or not they torque to spec. And what I found out is that people that work in an industrial or commercial environment tend to torque to spec, or especially if they're working in like a plant or something. But a lot of time on residential, you don't see them torquing to spec. Typically when you do something like that and torque to spec, you would torque it with a torque tool and apply the right amount of pressure in the terminal, and then you're gonna mark it so that you've shown you torque it to spec. This is the tool that I'm using. If you watch Project Farm on YouTube, this one's highly reviewed, and I check it periodically against my calibrated torque wrench. But I've had so many conversations with electricians, and most of them just tell me to go get one from Home Depot. So I don't worry a ton about this. I do wiggle the conductors as I'm tightening them, and we get them pretty dang tight anyway. It's not like I'm running around seeing these lugs burned up or seeing these lugs burned up. But I have heard that on car charger circuits, they are starting to see stuff melt. That's when things really run at full load. So I'm gonna go ahead and torque to spec. This one runs in foot-pounds. So when I do that, I have to convert foot-pounds to inch-pounds, because the wire tightening torque says 275 inch-pounds for these terminals, or lugs, if you want to call it. So in order to do that, you would take 275 inch-pounds, divide it by 12, and that's going to get you your foot-pounds. Sorry for the filming like that. With aluminum wire, you don't have cold flow as much, but with copper wire, you can actually have cold flow where you tighten it down, and then when it, like 15 minutes later, it's moved a little bit and it might be loose. So you want to torque these down and then come back and torque them all to spec a little bit later. So I'm going to go ahead and do that with my torque tool. I'm not saying this is the one you need to buy. I'm not giving you electrical advice at all. I'm just showing you what I do. I'll show them that. All right, so one thing I think about every time I torque the crap out of something is, am I cutting the strands and the wires? So I'm sure any guy that thinks enough about what he does is going to wonder about that. So we're going to go ahead and strip a piece of wire out with our Klein Tools stripping tool, and we're going to land in this. Since this is a 3-phase disconnect, we've got an extra lug that we can land in. So 275 inch-pounds is the required torque for this terminal. That's where it says it. So I want you guys to understand that 275 inch-pounds, which is about 22.9 foot-pounds, is killing it. When you tighten a wire down this tight, you're thinking in your mind, am I cutting the wire with the set screw and the lug? Now I realize everybody has different definitions of tight, right? What is tight? What is your definition of tight? Antonio's background is a lot of mechanical stuff, so he's really good at having a feel for how tight things should be. But still, when I come behind him and start torquing stuff down, there's always a lot of tightness to be had. So my recommendation to you guys is to use some kind of a torque tool when you're making these big connections. 22.5 inch-pounds, 22.6. Oh, it's loosened, it's on loose. And it starts to tell you, hey, keep going. Try to hold it straight so you don't. Okay, so that was it. So now, take it out. I want to see what happens, because that's all what I was wondering, is could that part that's splayed be cut? Could the aluminum be cut by the lug when you're killing it like that? And the answer is no. No. There we go. Barely even dents it in. So I would always think, or a lot of time I think to myself, am I just killing this? But I'm not. And I want to show you guys one other thing, the kind of grease we're using. This is, show them that grease, Antonio. Just put a little bit on there. So this is utility stuff, and I just like it better than, yeah, this is it right here. I don't know why I like it better. It's called Deox. Why do you like it better? Not as sticky? Not as sticky, doesn't stain. I just feel like it's better than that gray stuff they sell at Home Depot. Places where I won't kill it is on an old breaker. If I'm gonna, once I get these wires loose, I'm not gonna go full torque on them. I'm just gonna go, I'm gonna go tight.